Let's start with the first example. We have log base 3 of 4 times log base 4 of 5. And we're going to multiply this all the way up to log base 8 of 9. This is a great example to use the change of base formula for logs. So to review, if I'm giving log base a of b, I can rewrite this with a new base. We'll call it c of b over log base c of a. So we're going to apply this formula for each one of these logs. The new base, I'm just going to have it as 10. It doesn't really matter which base I choose, but 10 is the standard one. And the last one will be log base 9 over log base 8. And now we can cancel things out. So we can cancel out the log 4s, 5s, all the way up to 8s. So now what's left is a log 3 and the log 9. So this will just be log 9 over log 3. And I'm going to use the change of base formula again, but this time I'm going to go in the opposite direction. So I'm going to go from right to left. So that's just going to be log base 3 of 9. And I'm going to let that equal x. So 3 to the x is 9, and that means x is 2. So 2 is our final answer. One thing I want you to pay attention to is that the final answer dependent on the smallest log and the biggest log. So what I mean by biggest log and smallest log, specifically the number. So 9 is the biggest number we see. 3 is the smallest number. So if we go back to the original problem. So 3 is the smallest, 9 is the biggest. And because 3 was the base, it goes in the denominator. Right? So the base goes in the denominator. And the other number goes in the numerator. So we're going to use this little shortcut, and we can apply that to the next problem. Okay. I have log base 3 of 2 times log base 4 of 3 times log base 5 of 4 all the way up to a log base 15 of 14 times log base 16 of 15. So if we want to use a shortcut, we would say that 2 is the smallest and 16 is the biggest. So this would just simplify to log 2 of log 16. And because the 16 is the base, it's going to go in the denominator. And because 2 is not the base, it goes in the numerator. And then from here, we can solve it. But let me just show you that indeed that's what it simplifies to. So we're going to use the change of base formula again. And we can cancel things out. So we can have the log 3s, 4s, let's see, the 15. And the log 5 will be from the next term. And then the previous term from log 14 will be on the denominator. So that would have been canceled out. So really all that's left is the log 2 over log 16, which is what we said in the previous step. And this one we'll use the change of base formula. The 16 is in the denominator, so that's going to play the role of the base. And we're going to let this equal x. So 16 to the x is equal to 2. I'm going to rewrite this as 2 to the 4th to the x equals 2. Exponent to an exponent you multiply. And we can think of the 2 as having exponent of 1. So 4x is going to be 1. And that's going to give us x equals 1/4. So that's our final answer. Okay, the next problem is going to be much more involved. So I have the square root of 1 over the square root of 27 all raised to the second minus log base 5 of 13 over 2 log base 5 of 9. The first thing I'm going to do is break this up. So we're going to have two exponents. So one of them will be the 2, and the other one will be the logs. And it's all going to be under the square root. If I square 1 over square root 27, the square root is going to cancel, and I'm just going to be left with 1 over 27. Then the negative in front of the log is going to do the reciprocal of square root 27. And then the 2 here is going to come out in front as the exponent. So it's going to be on top of 9 as an exponent. So I can rewrite that as log base 5 of 13 over log base 5 of 9 squared, which I'm just going to leave it as 81. And that's all going to be under the square root. The next step is to rewrite log base 5 over 13 and then log base 5 over 81. That as a new log using the change of base formula. So I'm just going to have 1 over 27 and then square root 27. So that would be log base 81 of 13, square root of that. At this point, I want to get the base, the two bases, so like the square root 27, the 81 to be the same. So there's multiple ways of doing that. One way, we can write it in terms of powers of 3, or we can do it powers of 81. Let's just do powers of 3, because there's a cool thing we can learn from this. So 27 is 3 cubed, and the square root of 27 will be to the 1/2 power. And then log base 81 is 3 to the 4th of 13. Okay. So for the next step, we want to use this little fact. Okay, so log base 3 to the 4th of 13. We'll let that equal x. So that means 3 to the 4x is equal to 13. Okay. If I raise everything to the 1/4 power, I have 3 to the x equals 13 to the 1/4 power. So I'm going to change that whole expression to be to the 1/4 power. And this 3/2 is being multiplied with the exponent of log base 3 to the 4th of 13, which is going to go on top of the exponent of 13. Okay. So that's going to be 1 over 27, 3, and then log base 3 of 13 to the 1/4 to the 3/2. And I did forget to rewrite this expression like this. Okay. So just to clarify, I started off with this, and the exponent went up to the exponent of 1 over 4. Okay, so you just did the reciprocal, and it was on top of the 13. And now I see that we have the 3's. So those are going to cancel each other out. We'll be left with 1 over 27, 13 to the 1/4 to the 3/2. Exponent to an exponent you multiply, and then you take the square root, which is really taking everything to the 1/2 power. And that will be 13 to the 3 over 16. And then 27 is 3 cubed. So this is 3 cubed to the 1/2 power, would just be 3 to the 3/2. And that's my final answer.